Hello students, today we'll revise playing with numbers. So let's begin with some fill in the blanks. So I have a few sentences here. I would like you to fill in the blanks first and then you can check your answers with me. So let's begin. First one, the smallest prime number is. The smallest prime number is 2. So we have all our prime numbers, keep that in mind. So you have to learn a few numbers, prime numbers by heart. Let me write a few here. 2, 3, 5, 7, 11, 13, 17 and so on. Okay, so the smallest prime number here is 2. Now the smallest composite number. What is a composite number? Numbers which are not prime are composite. So which is the smallest number that is left out here? So if you look out here and see, we have 2, 3 and then we have 5. So what is missing in between? In between we have 4 missing and then here 5, 6 is missing, 7, 8, 9. So all these numbers in blue that are missing are not prime numbers, isn't it? The numbers in red are the prime numbers. The numbers in blue are the composite numbers. So numbers which are not prime are composite. So here, which is the smallest composite number? As you can see, 4 is the smallest composite number. So let's write our answer there, 4. Which is the only even prime number? You know what even numbers are? 2, 4, 6, 8, 10, isn't it? All those numbers are even numbers. Now, which is the only even prime number? If you look at all the prime numbers other than 2, they are all odd numbers. So 2 is the only even prime number. So the answer is 2. Which is the smallest odd prime number? So the smallest even prime number is 2. The smallest odd prime number will be 3. So let's try and answer different questions. Now, which is the number which is neither prime nor composite? So as you can see, all these numbers are either prime or composite. Now, which is a number which is neither prime nor composite? That is the number 1. Okay, 1 has only one factor. 2 has two factors. The prime numbers have two factors. Composite numbers have more than two factors. 1 has only one factor. So this is called a unique number and it is neither prime nor composite. Now, dash is a factor of every number. 1 is a factor of every number. All multiples of 2 are called even numbers. 2, 4, 6, 8, 10, 12, etc. Now, dash cannot be the factor of any number. That's 0. 0 cannot be the factor of any number. Now, questions 9 onwards, again, it's all displayed. First, write out the answers and then cross-check it with my answers. A number which has more than two factors is called a composite number. So a number which has more than two factors is called a composite number. Question 10. Any two numbers that do not have a common prime factor are called co-prime numbers. Okay, co-prime numbers do not have any common prime factor between them. If a number ends in 0 or 5, this is question 11, if a number ends in 0 or 5, it is divisible by 5. Question 12. A number is divisible by 6 if it is divisible by dash and dash. So if a number has to be divisible by 6, it has to be divisible both by 2 and by 3. Question 13. The greatest two-digit prime number is dash. So I hope all of you know all prime numbers up to 100. So in that, which is the greatest two-digit prime number? The greatest two-digit prime number is 97. Next one, the smallest two-digit prime number. The smallest. So let's try and remember all the prime numbers starting from 2, 2, 3, 5, 7, 11. 11 is the smallest two-digit prime number. Question 15. The number 20,316 is divisible by 3. The other numbers that can divide it are, what are the other numbers that can divide this number? Using the test of divisibility, we can think of a few numbers that can divide this. Now, if you look at the last digit, in the ones place, we have 6, which is an even number. And if it is an even number, it is divisible by 2. Now take the last two digits. The last two digits are 16. Now the last two digits form the number 16, so it is divisible by 4. It's divisible by 4. And since this number is divisible by 2 and by 3, it is also divisible by 6. Question 2 simplify. So we have BODMAS sums here. So let's follow the BODMAS rule. BODMAS will tell us the order in which to work out our different operations. So B stands for brackets, O for off, D for division, M for multiplication, A for addition, and S for subtraction. So according to this, we have to work out BODMAS first, okay, and then go in the order. Now here the two operations that we have are multiplication and division. Which one should be done first? According to BODMAS, we should do division first. So let's do this. So this will be 12 into 16 divided by 4. How much is 16 divided by 4? 4 fours are 16. So this becomes 4. So this is equal to 12 fours are 48. So this is our answer. 12 fours are 48. Question 2. As you can see, we have minus, we have brackets, we have curly brackets, common brackets, and the bar bracket. So bar bracket should be done first. As you know, in BODMAS, brackets to be done first. And even in brackets, there are different brackets and we have to follow a particular order. The bar bracket to be done first, then the common bracket, then the curly bracket, and then the square bracket. So bar bracket will be above the numbers. Common will be like this. And curly, you have the curly brackets like this. And finally, the square bracket. So according to this, we need to work out this first. So we have 4 minus 3 and we have the bar bracket, isn't it? 4 minus 3 is 1, but before the bracket we have a minus sign, so that's minus 1. So let's write that 24 minus square bracket 19 minus curly bracket 6 minus common bracket 5 minus 1. So bar bracket is removed. So we have the common bracket, curly bracket and the square bracket. So according to BODMAS, we should do the common bracket next. That means this. We need to work out this. So let's work out 24 minus square bracket 19 minus 6 minus, now 5 minus 1 is 4 and before that we have a minus sign, so it's minus 4. So the common bracket is removed. We put back the curly bracket and the square bracket. So we finished with the common bracket. So now we have the curly and the square bracket. We have to do the curly bracket first. So let's do that. This is what we need to do. So 24 minus square bracket 19 minus, now 6 minus 4 is 2. It's plus 2. Before the bracket we have a minus, so it's minus 2. So curly brackets are removed. Now we have only the square bracket. So 24 minus 19 minus 2 is 17. So how much is 24 minus 17? So borrow 14 minus 7 is 7. So what do we have? We have our answer as 7. Question 3. Here we have brackets. Once more we have brackets. So first let's remove the common brackets. So the first one, let's work out. So this is 120 minus 12. So 120 minus 12, let's do that. So here we borrow this 1. 10 minus 2 is 8. 1 minus 1 is 0, 1. So here we have got 108. So this is 108 divided by, now 36 divided by 3. So let's divide 36 by 3. 3 ones are 3 minus 6. 3 twos are 6. So we've got 12. So it is divided by 12 minus 22 plus 7. So as you can see, we have different operations. We have division, subtraction, addition. According to BODMAS, we must do division first. BODMAS, D comes before subtraction and addition. So let's do this. 108 divided by 12. So 108 divided by 12. Now 12 into 9 is 108. So 12 nines are 108. So when you minus, you get 0. So let's write that down here. So here we've got 9, isn't it, when we divided this? And let's write the remaining minus 22 plus 7. Now we have to do addition. So when you add, we have to add up these two numbers, the numbers with a plus sign. So that will be 9 plus 7, that's 16. 9 plus 7 is 16 minus 22. So here signs are different. So put the sign of the bigger number and subtract. Subtract 22 minus 16. So here borrow 12 minus 6 is 6. So what is our answer here? Minus 6. We have put the sign of the bigger number and that is subtraction, minus sign. Okay, so the answer here is minus 6. Question 3, here we have some questions based on test of divisibility. So the first question is the number 5,14,624 divisible by 11? Now what is the test for 11? The test for 11 is you take the numbers which are in the odd places starting from the right side. So from the right side, the number in the odd places are 4, 6, and 1, isn't it? That means it's in the first place, the third place, and the fifth place, odd places. So we have to add it up. So 4 plus 6 plus 1. What do we get? We get 11. Now take the numbers in the even places from the right again. So these are the numbers 2, 4, and 5. So let's add up those. 2 plus 4 plus 5. So what do we get here? 2 plus 4 is 6, 6 plus 5 is 11. So we've got two answers here. We've got one answer here and one more answer. Now we have to find the difference between the two answers. Subtract both. 11 minus 11 is 0. So if your answer is 0 or if it is a multiple of 11, like if it is 11, 22, 33, 44, if it is either 0 or one of those, then it is divisible by 11. Now since it is 0, this number is divisible by 11. So we did not do actual division. Without doing actual division, we have found out that this number is divisible by 11. So this is our answer. Yes is our answer. Question 2, is the number 12,834 divisible by 9? Now what is the test for 9? We have to add up all the digits. So let's add up 1 plus 2 plus 8 plus 3 plus 4. Let's add up and see what we get. So we have 1 plus 2 is 3, 3 plus 8 is 11, 11 plus 3 is 14, 14 plus 4 is 18. Now 18 is in the tables of 9, isn't it? 9 twos are 18. So the answer to this is yes, this number is divisible by 9. So now let's go on to the next one. Is the number 38,705 divisible both by 5 and 10? Okay, what is the test for 5? The number has to end in 5 or 0. So it's ending in 5, so it's divisible by 5. What is the test for 10? The number has to end in 0. But here the number does not end in 0. So it is not divisible by 10, but it is divisible by 5. So we can write our answer saying it is divisible by 5 but not by 10. But not by 10. If it has to be divisible by 10, it should end in a 0. The ones place should be 0. Okay, next one. Is the number 9,30,452 divisible by 8? Now what is the test for 8? For 8, we have to take the last 3 digits alone. You don't have to take the whole big number. Take only the last 3 digits and see whether it's divisible by 8. You can do short division or long division. Okay, so let's do long division if that's easier for you, and take only the last 3 digits and divide and see. Okay, so 8 5s are 40. And then we have 52. 8 6 are 48, 8 7s are 56. So 8 6s are 48. And here, as you can see, our remainder is 4. That means this number is not divisible by 8. If the remainder was 0, then we can say it is divisible by 8. So this answer is no. This number is not divisible by 8. And what do we mean when we say divisible? The remainder has to be a 0. Okay. Question 4. Write the first 5 multiples of 18. What are multiples of 18? The answer that you get when you multiply 18 into 1, 18 into 2. So the answer that you get when you multiply the number. Okay. So we have to write the first 5 multiples. So let's multiply and get these answers. So 18 ones are 18. Then 18 twos, 2 8s are 16, carry 1, 2 ones are 2, 3. 18 twos are 36. Then we have 18 threes, 3 8s are 24, carry 2, 3 ones are 3, 4, 5, 54. Then 4 8s are 32, carry 3, 4 ones are 4, 5, 6, 7. 5 8s are 40, carry 4, 5 ones are 5, plus 4 is 9. So we've got the 5 multiples, the first 5. So when they say first 5, we need to write the first one, which is 18 itself. Then 36, 54, 72 and 90. Next question, write all the factors of 24. Factors of 24 are numbers that multiply to give us 24, isn't it? So if we see 1 into 24 will give us 24. Then 2, yes, 2 12s are 24. What about 3? 3 8s are 24. 4, 4 6s are 24. Anything else? That's it. So these are the factors of 24. Question 6. Write all prime numbers less than 30. Okay, so let's try and write all prime numbers less than 30, starting with 2, 2, 3, 5, 7, 11, 13, 17, 19, 23 and 29. So these are all the prime numbers less than 29. Question 7. What are the prime factors of 140? So we need to find the prime factors of 140 by dividing 140 by prime numbers. So let's do that. So let's take 140 and begin by dividing it by 2. Divide only with prime numbers. 2 7s are 14. Okay, 70. Now I can take 7 itself because 7 is a prime number. 7 10s are 70. Now I can take 2 again. 2 5s are 10. This time I have to take 5. 5 ones are 5. So these are all the prime factors of 140. So what are all the prime factors of 140? 2. 2 is repeated, so we can write it only once. Then we have 7 and we have 5. So the prime factors of 140, 2 from small to big, 5 and 7. These are the prime factors of 140. Question 8. Find the H.C.F, the highest common factor of 12, 18 and 24 by the common factor method. There are many methods, so be careful to read your question carefully and understand. So the first method that we're going to do is common factor method. So let's begin. So first thing you do is find the factors of 12. Write out all the factors of 12. So 1 12s are 12. Now I'm going to leave a gap and write so that I can fit in all the other numbers in between and go in ascending order. So 1 12s are 12. So I finished with 1. Let's do with 2. 2 6s are 12. Then let's do with 3. 3 4s are 12. That's it. We've got all our factors. Now let's get the factors of 18. Again, starting with 1. 1 into 18 is 18. Then 2. Yes, 2 9s are 18. What about 3? 3 6s are 18. So we've got all the factors of 18. Now factors of 24. 1 into 24 is 24. Then 2. 2 into 12 is 24. What about 3? 3 8s are 24. And then we have 4. 4 6s are 24. So we've got all our factors and I've put them in ascending order, small to big. Then now we have to pick out the common factors from these. Common means it should occur in all three numbers. So here we have 1, here also we have 1, here also we have 1. So 1 is a common factor. Now let's go to 2. Yes, 2 is there for all three numbers, the factor of all three numbers. So 2 is also a common factor. Now let's see 3. Yes, 3 is also common. I have 3 there and 3 here. So 3 is there. Now what about 4? 4 I have here, but I don't have 4 here. And I have 4 here. So 4 is not a common factor because it's not here. What about 6? 6 is common to all three numbers. So 6 is a common factor. Okay, so let me write down 6. Now, is there any other common factor? Now, I have 12 and 12, but I don't have 12 in between. So 6 is the common factor here. So these are the common factors, 1, 2, 3, and 6. So now we have to pick out the highest common factor. So among these numbers, 1, 2, 3, and 6, the highest one is 6. So what is our HCF? Our HCF is 6. So that is our answer. Question 2. Find the HCF of 25, 40 and 100, this time by the prime factor method. That means we must find the prime factors of all these numbers first. So let's do that. So first step is we are going to find the prime factors of 25. And that means we're going to divide 25 by prime numbers. 5 is a prime number. 5 5s are 25. So that is 1. So the prime factors of 25 are 5 into 5. Next is prime factors of 40. So let's find the prime factors of 40. Starting with 2, 2 into 20. Then I get 2 10s are 20. 2 5s are 10. And then I write 5. So what are the prime factors of 40? 2 into 2 into 2 into 5. Now we have to find the prime factors of 100. So let's do that. 100, I can start with 5 itself. 5 2s are 10, 20. I can continue with 5. 5 4s are 20. Now I go to 2. 2 2s are 4. And then again I get 2 1s are 2. So let me write all the prime factors of 100. So that starting with 2. 2 into 2. There are 2 2s and there are 2 5s. So now I need to find a common prime factor. So from that I can find the HCF. So how to find the HCF? I need to take the common one. So I have 5 which is there. 5 is here and 5 is here also. So I can write 5. Now do I have anything else that's common? I don't have anything else that's common. So 5 is my HCF. Now suppose I had 2 also common. Now suppose I have 5 and I also have 2. Then I multiply it. Okay, I write 5 into 2 and get the answer. But here I only have 5, so 5 is my HCF. Find the HCF of these three numbers by the division method. So this is a third method, and generally for big numbers we use the division method. So let's begin. Let's take the first two numbers. So we'll take 405 and 513. So let's divide 513, the bigger number, by 405. So 405 ones are 405. Then we subtract. 3 minus 5 you can't do, so you borrow from here. 13 minus 5 is 8. 0. 5 minus 4 is 1. So we continue, and here we have 405. We put that inside. Now we need to multiply 108 and get a number close to 405. So let's try 108 into 3. 3 8s are 24, carry 2. So you bring down 2, 3 1s are 3. So we can use this. 108 into 3 is 324. Now let's subtract. 5 minus 4 is 1. Now here we can't do, so we borrow. 10 minus 2 is 8. 81, and again we continue our division. So this time we put 108 inside. So 81, 1s are 81 minus 8 minus 1 is 7. Then we borrow. 10 minus 8 is 2. So here we have 27. 27, and now we put 81 inside. 27 into 3. 27 into 3 is 81. So minus. So now the last divisor. This is the last divisor. Okay. This last divisor which gave us 0 is going to be used to divide 783. So let's divide 783 by 27. 783 divided by 27. So 27 ones are 27, 27 twos, 27 twos are 54. So we can use that. 27 twos are 54 minus, we have not completed this division. Okay. So 8 minus 4 is 4. And then we have 7 minus 5 is 2, 24. And then we bring down 3. Now 27 into what will give us a number close to 243. Let's multiply 27 into 9 and see. 7 nines are 63, carry 6. 9 twos are 18. 18 plus 6 is 24. So we've got the same number. 27 into 9 is 243. So our remainder here is 0. So we didn't have to continue with our division because when we divided by 27, we got the remainder 0. So 27 is the last divisor which gave us the remainder 0. So let's write the HCF of these three numbers. What are the three numbers? 405, 513 and 783 is 27. So this is our answer. This is the HCF. We will stop with that for now, children. In our next video, we will continue with playing with numbers, revision 2.